So, homeostasis, as we get into heat and body temperature, we need to understand what homeostasis is. The body's temperature is very regular. The core temperature changes slightly. Changes only slightly with exercise or illness. But all in all, your body temperature is very regular. Um, the outer portions of the body, the skin, can vary a lot based on the environment. So if you measure the temperature of your fingertips, they can be quite a lot less than the temperature of your core. Sources of heat are the metabolic processes in the major organs. The liver, the heart, the brain, and the skeletal muscles. Heat is lost through the skin by the three methods, which include conduction, convection, and radiation. Including evaporation. It's going to be sort of a special. It's not really in these three. There are only these three, but we'll talk about evaporation because that's going to be a very important part of heat loss in the body. So within heat loss in the body, we have examples of all of these. Conduction, well, the organs are at a higher temperature than the skin. So if I imagine my organs, let's say this is my organ, it's connected to my skin. I'm going to have a heat flow moving in this direction because my organ has a higher temperature and it's going to conduct heat out to the skin. Convection, cool air comes into contact with warm skin. I remember when I was a kid, we didn't have air conditioning, and I remember as a kid standing in front of the fan in our house just to cool off. So as we saw in the previous section, like with the convection oven, convection can be a very effective, efficient method of heat loss. And then radiation, warm objects emit infrared radiation. I have a video I want to show you. That video will show the infrared radiation that the human body puts out. Or if you're in class, we'll do that in class. And then evaporation is through sweating. Okay, let's talk about this for just a moment. So imagine this is the surface of your skin. All right, you get these little droplets of sweat on the surface of your skin, and those droplets of sweat are liquid. But when they evaporate, they turn into a vapor. And remember, when we were talking about phase changes and the latent heat of vaporization, the amount of heat that's lost when I go from a liquid to a vapor, the amount of heat required to change a liquid into a vapor is governed by this, that Q is equal to MLV. Remember I showed you that phase change diagram where we had the different phase changes and that it required a lot of temperature. This isn't a very good picture, but it required a lot of temperature to take a 0 degree, or excuse me, 100-degree liquid and turn it into a 100-degree vapor. So the latent heat of vaporization is very large, and because of that, when I have a liquid that turns into a vapor, it takes along with it the latent heat of vaporization, which is an energy, and it takes that away from your body. That's why cooling stations often include misting, that when you put that water under your skin and it evaporates, it will take away a lot of energy. Evaporation is really what form of heat transfer? Well, this is a little tricky, but evaporation is a form of conduction because when I have this vapor, the energy that it takes away, that energy is taken away from your skin. It sucks energy away from your skin and then causes that liquid to turn into a vapor. The amount of heat loss you might be surprised by, conduction and convection in the body is only about 20%. We lose about 20% of our body's heat through that. And then radiation is about 50%. So the human body loses about 50% of its energy just through radiation. You basically look like a light bulb in the infrared. And as I said, I'll show you a video. Evaporation, when you have evaporation on your skin, is about 30% of your total heat loss. Typically, the body produces about 100 watts of heat, and again, this all comes out in radiation. But heat gain and loss can be affected by a number of things, and your book talks about each of these. You can take cool or hot showers, especially if you sleep really hot. A cool shower right before bed will really lower your core temperature and just allow you to be cooler through the night. You can drink cold or hot liquids. In the wintertime, I'll often drink hot tea just to stay warm. You can insulate the body, put on more clothes. You can use forced convection. Like if you don't have AC, you go stand in front of the fan. You can have evaporation. And while this is an involuntary process, you can hasten it by putting water on the skin. And then finally, you can have radiation. For example, go sit in the sun, right? If you're cold, go sit in the sun and you will collect radiation from the sun. So how does the body regulate its temperature? Well, the brain or the hypothalamus region can increase or decrease the amount of heat generated based on the info from heat receptors in the core and the shell of the body. And we'll talk about how that happens in our chapter on electricity. But it regulates through several actions to prevent heat loss. So 3 things that you need to know: that blood vessels in the skin contract, and that causes less blood to the skin, which means that you have less heat loss. Okay, you can have shivering. This produces heat. And you can release chemicals to increase the BMR. And this also produces heat. So actually all of these will prevent heat loss or will produce heat. Then there are a number of voluntary actions we talked about, like taking a hot shower, drinking a hot liquid, putting on more clothes. All those things will help to prevent heat loss in the body. So a couple more things here. There are also some ways to enhance heat loss, that is, to cool off. The blood vessels can dilate. Or they open up. So just like before, when the blood vessels contracted, that causes less blood flow to the skin, and that prevents heat loss. If the blood vessels dilate or they open up, then you get more heat, more blood flowing to the skin, and that causes you to look flushed. Maybe you look red. Then your skin feels warm. That's for losing heat to the body, trying to cool the body. And then also, of course, sweating. There are two conditions: hyperthermia, where the temperature is too high. This can result from a fever, which helps to produce white blood cells and fight infections. Or two, it can be uh, from exertion, overexerting your body, often a high temperature, dehydration. The football video that we watched talked about this a bit. And then hypothermia is the temperature is too low. All right, that's it for that. Next, we'll look at specific heat.